Welcome to the assembly tutorial on how to create an assembly in SolidWorks. Now before I start, what we need to do is we need to get all of our parts together like this. You can put them on your desktop, you can put them in your Windows Explorer, however you want to do it, but we need to create a new, I got this box up by right clicking the desktop, clicking new folder titled with your name. Now obviously this needs to be your own name, and then I'm just going to highlight all of these, drag them into there. Now wherever this folder stays, wherever this folder is when you open SolidWorks is where it needs to stay. If you move this folder you're going to have problems. I'll explain this later on in class, however make sure that this is the first step that you do. You title the folder with your name and all the parts inside the folder. If I share this with you now, you can see they've all got a reasonable name. And if I make this a little bit bigger and I press and hold Control and scroll upwards with the mouse button, it will show me a little picture of what they all look like up to a certain point. So wishbone mount 2, wishbone mount, wheel assembly, tyre, we have a lot of various different components here. Now this is a student from last year who did this. So I'm going to open up SolidWorks. I'm going to make sure that this is fitted to a screen, and I'm going to open a new assembly. I'm going to double click on assembly. Now because my computer is mighty slow, it takes a while for SolidWorks to think about this. Here we go. So it looks very similar to creating a new part. However, you can see that the tabs have changed. We've got assembly, layout, sketch, evaluate, render tools, etc. What we want to do is begin the assembly. We want to browse, and what you want to do to browse this, you want to select the center component that will not move. So if you're doing the damper, it's going to be the damper body. If you're doing a wishbone, it will probably be part of the wishbone mount, where it mounts on the inner. So I'm going to go and find mine, and mine's on my desktop. It's the folder titled your name, and again I'm just pressing and holding Control and scrolling up, and I want to find wishbone mount. So I'm going to select this, and then I should get a visualization of it. I'm just going to click it anywhere to locate it, and now when I locate that there, the part is fully defined and it cannot be moved. The selected component is fixed, it cannot be moved. So these remote control cars are slightly different to the ones that you're using. I will demonstrate how in a moment. So then what I want to do is I want to insert more components. Now the next component that I want to insert, I'm going to press insert components, I'm going to browse, and now I want to insert the wishbone, so I can just double tap that. Now we can see that the wishbone has been put there, and I can move this wishbone wherever I like. It can intersect that part, it can move a long way away from it, wherever you want it. Now what I'm going to do is I am going to move the component, and I'm going to rotate the component. So I'm just going to drag this, and I'm going to kind of get it in the orientation that I want, about there. Press OK. Now when you assign a mate to a part in an assembly, there will be various different relations that you can use. So if I at the moment I have that face selected, I'm just going to click in the white area, and there's going to be no face selected. Then I'm going to press mate, and you can see the mate selections is blank. If I just close this and I reselect that face, and then I press mate, it has already selected the face that I was in before I pressed the mate button, if that makes sense. So this could cause you some problems. If that's the case, you can just press the X and you can click mate again, and then you can select what you want it to do. Now these are the standard mates. You've got coincident, you won't use a lot of. Parallel, you may use. Perpendicular, probably not. Tangent, possibly. Concentric, definitely. Coincident, definitely. Parallel, possibly. Tangent, maybe. Concentric, definitely. What I want to do is I want to select that, and I want to assign a mate with that circular shape there to that circular shape there. And then you can see the part has now rotated, and anywhere I move that, it will stay on that axis of revolution. Those two parts share the same, those two circles share the same centre. Excellent. Now I can move that there, and I can put it in approximately the right place, and then I can just click another two faces, that face and that face, and it's giving it a coincident relation there. I can press this green tick here, or I can press this green tick here. Now what I've got is I've got a wishbone that will rotate around there. This surface is not just touching, but that surface perfectly touching, because we have the coincident relation there. So that is as far as I want to take this wishbone. I don't want it to go any further than that. And you can start to see how it's mounted to the remote control car. So we'll press OK. Now we want to insert more components. We're going to browse, and not 100% sure, so I'm kind of working this out as I go. I'm going to put the back plate in. I'm going to open that up, and I'm just going to drop it there. If I rotate this component round, we can see that these two holes here, this one and this one, screw into that one and that one. So press OK, and then we want to mate that surface, that hole, into that hole. Press OK. Then I want to mate that hole into that hole, and press OK. So now, no matter where I put this, oh, it hasn't done that second one, done that one. Okay, the problem here is that those two holes are lined up, perfect alignment somewhere near there, but when I move this, I'm just moving the depth of this part here. So to cure this, I'm simply going to give a mate between that face and that face, and then press OK. It's still not just as I want it. We can cure this by making that and that parallel. Okay. So if this was, you can see that these two holes can't be perfectly aligned. They can't share the same centre because of how the part has been designed. It's been designed with a little bit of inaccuracy. But now that's fully defined, it cannot be moved, because we have made sure that that's parallel with that, and that hole is concentric. So looking somewhere near. Okay, so next step, we need to insert another component. We're going to browse, and I'm going to fire in this ball joint. Open. Now this ball joint lives, I'm going to mate that surface into that surface, and you can see there it's going the wrong way. If I press that button, flip, it'll flip it round. Press OK, I can drag it up, and then I can assign a mate between that face and that face. Press OK. Then I want that surface to be mated to that surface. Okay, so there we go, that's now located in there. There is a nut that goes on the back of that, I believe. Insert browse, we'll find our nut, open it, put it there. Dead simple, mate between that circular face and that circular face, okay, and then that flat face to that flat face, okay. Now you can see this student hasn't done any threads on their work. This was a time issue that we were having, and press OK. Now I think that this may be the wrong way around. I think I need to flip that round, but I'll work it out as and when. I'm just going to fire some more components in there so that you can start to see how these things are built. I want to put in hub 1, let's try that. I'm going to put that there. This is the stub axle, this is the steering arm. I don't want that one, I want to browse. This is the I'll work that out in a minute. I'm going to insert the other hub part. R1's opposite, hub part 2. So I'm going to delete this one, yes, and then I'm going to work out where this one goes. I think if I mate that surface onto that surface, press OK, and I drag this down, and I then mate that to that, OK. So I'm going to then put the other thing with these circular faces, I can make that circular face to that circular face, press OK, and then I can make that surface to that surface, okay. Now when that comes round here, something like this, you can start to see how the assembly is going to look. And it's all about creating these coincidence, parallels and concentrics, and if you can be doing that, you're well on your way to completing this. Getting the pins in as well, this is important. These pins, simply concentric mate to there, oops, add a mate. Now because I already had that selected, I can now select that one. Dimensions a little bit out on this one, select that surface, mate to that surface, press OK, and then that's the pin that holds the whole thing together. Now you don't need it for the assembly to work, but to check your dimensions and everything, it needs to be in there for the assembly. Press OK, insert components, I'm going to browse, and I am going to put in another one of these ball joints. Open, put that in there, mate that to that, press OK, and then I can make that surface to that surface, press OK. So even though the dimensions are a little bit out, this you can still see that this part is wanting to work, because SolidWorks will just override any interferences, but you will score less marks if this is your approach. Ball socket, open. So put the ball socket in, I'm going to move it into a place that I want, I'm going to put a mate in. So I want to mate that spherical in there to that spherical, which is giving you a tangent relation, which it has to be. Press OK, and then press OK, insert more components, browse, the top arm, so if you again not 100% sure how this model goes together, put that face into there, flip it round, press OK, you can drag that out and then you can even add a mate between that surface and then find the one in there, mate it to that, press OK. So yeah, it starts to get a little bit tricky if you're not doing it 100% accurately. I'm going to see if I can open the actual part of this. Let's have a look. Assembly. So this is this is because I've moved all the files out of the original folder, and that's what it's supposed to look like. If I view the report, close that, all the parts that I've just used have been hidden. However, this is what it's supposed to look like, and when you move this, I dare say, it's left some parts behind, but that's because I've been fooling around with the file structure. Now, the file structure, don't save that. If I file, save as, rebuild and save, and I go to my desktop, I go to your name, save it as an assembly, and I'm going to save it as final assembly 1. Save. Saving will convert the files to current version. This is because the old files were 2015 version. OK. Press OK. Yeah, brilliant. It's saved. Don't save. If I then open my final assembly 1, excellent, it works. So let's just consider for a moment that this is my file. This is my your name folder. If I remove these two, or say for example I remove these two and I put them somewhere else, so it's moving them, can't be complete because it's being used in SolidWorks. So if I close that, minimize that, so let's say we rename this to be Wish Space Bone, and we put this one on the desktop. Okay, if I try and open this again, suppress this component, the blue thing and the wishbone are now non-existent because SolidWorks can't find them. And if we view the report, it's looking for users eRushton desktop your name wishbone mount, which is now on the desktop, users desktop your name wishbone. It's not found that because it's now called Wish Space Bone. So if I close that, I would need to insert the components again or tell SolidWorks where those components are. So undo that, don't save, minimize that. I'm going to change Wish Space Bone back to Wishbone, and I'm going to put this one back in here. So now when I open this, success, because it's been able to search through my file system and it's been able to find these. So when you submit your files through the Canvas interface, you are going to need to submit them in a logical file structure, and you're going to need to zip the folder and submit the folder. There's going to be a tutorial on this. If you know what I'm talking about, brilliant. If you don't have a clue what I'm talking about, we're going to do tutorials on this after Christmas. You can also file. Now this is for those of you who know what I'm talking about. File, you need to pack and go. Now what this will do is it'll save a very large file with all the part information contained into it. So it's going to say, yeah, save to file, yeah, brilliant. Save. So it's going to replace my existing assembly. Yep. So now close this, minimize this. If I have a look at the properties of this, it should be quite a large file. think that's worked. Yes, it has. It's been able to find all them parts because I selected Pack and Go. Now Pack and Go, very important, it will save part information as opposed to part location. Something similar that you might have seen before is if you save all your music in your iTunes player or your Windows Media Player, and you add it from your downloads folder where you've just got the music from, then one day you come around to sorting your computer out and you move all your music out your downloads folder into your music folder. So you open iTunes and you ask it to play something, it says can't play this, you need to locate it, because you need to tell that program where this file is, because iTunes doesn't save the music file, it just saves a path to find that music file on your hard drive. And this is exactly what SolidWorks does. It just saves a path on where to find that part on your hard drive. So if you start playing around with the file system, it ain't going to work unless you use Pack and Go. But what I'm suggesting you do is just keep it in a logical order. When you save your assembly, Pack and Go. Submit that as a zip folder to me, I'll be able to find it, and then it'll work. Because if I open it and there's no parts there for me to mark in your assembly, you'll get marked as though you haven't produced an assembly. So when you submit your parts, I need all your individual part files, and I need your assembly file packed and goed. Pack and Goed. Something like that. You need to use Pack and Go. Right, I can see this video is getting on for 22 minutes now, so I'm just going to wish you a Merry Christmas, all the best, see you in January.